Hello, today we're learning to interpret data using pictograms. We're also learning to solve one-step and two-step questions using information presented in pictograms. What do you remember about pictograms? Have a think about that. Well, in our previous learning, we have collected data from a survey. One example is on our favourite pets or even our favourite colours. This data has been collated here in a tally chart. Do you remember learning about tally charts? So our results from a survey were collated and recorded in a tally chart. So each of these gates represents 5. 1, 2, 3, 4, 5. So in total, the people who chose red, the number of people, was 11, and so on for the different colours. That data can then be put into a results table and also presented in a pictogram or a bar chart. Here's an example of a pictogram, which is a way of representing the data. Other types of charts that we've used previously include bar charts. You may remember using pie charts and recording results in tables. And data and statistics are really important vocabulary that we need to use as well. So it's really important to understand the value of data and statistics in everyday life. For example, in the medical field, scientists have found cures through conducting studies and experiments. They ask questions, they collect data which can be organised and interpreted using charts and graphs. In Year 3, as scientists, we've conducted many experiments where we have made predictions, asked questions, and tested these things under experimental conditions. We have collated our data and represented our data in results tables as well as bar charts and other types of graphs. From this, we're able to see patterns and explain our results and look at what they actually show through investigation. So, pictograms are our learning focus today. A pictogram is a chart that uses pictures to represent data. Pictograms are set out in the same way as bar charts, but instead of bars, they use columns of pictures to show the numbers involved. Here is an example of a pictogram of favourite fruits. The sample used here were children, so each picture of a banana represents 2 children. Each picture of each fruit represents 2 children. So what does this data, which is information, what does it actually show? Let's take a look. How many children chose bananas? Is it 5 children? Well, 1 banana is equal to 2 children, so it's 2, 4, 6, 8, 10. How many children like apples? So 1 apple is equal to 2 children, so that would be 2, 4, 6, 8. How many children like pears? So that would be 6 children. How many children like grapes? So 1 picture is equal to 2 children. So that would be 2. So let's take a look at this data and take a look at the most popular fruit. So which was the most popular fruit? Well, as we can see here, bananas have the most value, 2, 4, 6 and 8. So that was the most popular fruit. Which was the least popular fruit? And it's really clear to see here, as the data is represented in this pictogram, that we only have one picture of a grape, which is equal to 2 children. So the least popular fruit was grapes. What's this pictogram about? When we look at the title, it says apples sold, and on this side here we have months. So it shows us how many apples were sold in January, February, March and April. Senna told Samir that 1 apple was sold in January and 2.5 were sold in March. Is she right? Have a think about it and explain your answer. So did she interpret this correctly? She forgot to look at the key, which shows us the value represented by one picture or symbol. So 1 apple is not just equal to 1, but is equal to 10. A picture of 1 apple, the value of that is 10 apples. She was wrong because the value of each picture of an apple is equal to 10 apples. So half an apple is equal to 5. So in January, how many apples were sold? So that would be 10. And in March, how many apples were really sold? So that would be 10, 20, and half an apple is equal to 5. So that would be 25. So let's interpret the data using this pictogram. Here we have a pictogram of favourite colours that children chose. 1 circle is equal to 2 children. How many children like blue? Make sure you take a look at the key carefully. How many children like red or liked red, blue and pink? How many votes did the most popular colour receive? Now this one might take you slightly longer. How many children voted all together? So we would need to add up the values to find out how many children were in this sample and voted. The next question says, what is the difference in the number of votes for green and red? So we would have to see how many children voted for red, how many children voted for green, and find the difference. So let's take a look at our answers. So 7 children in total, 2, 4, 6 and half is equal to 1, which is 7. 7 children chose blue. So red, blue and pink all together, all the values were added, and the answer, the total is 21. How many votes did the most popular colour receive? It's really easy to see because we look at the tallest bar here with the pictures on. And we will see that it's 2, 4, 6, 8, 9. How many children voted altogether involved adding up the total of children who voted for each colour, which is equal to 35. So the difference in the number of votes for green and red was really straightforward. It's 3, which is 8 take away 5. Here is another pictogram to show the money raised for children in need. So each picture of Pudsey Bear is equal to £10. These questions relate to how much money the different classes raised for children in need, for the Children in Need charity. In this column here, we can see the different classes, and these pictures on our pictogram relate to the amount of money which was raised in each class. And these questions relate to this pictogram. You will use the Purple Mash link to find the linked online activities. Also, check the Purple Mash uploads for the Pudsey worksheet linked to the video lessons on interpreting data using pictograms. Thank you.